NASA's James Webb Space Telescope, JWST, made a groundbreaking observation in August 2024 when it reportedly imaged a faint object near Alpha Centauri A, the closest Sun-like star to Earth. The object, detected at about twice Earth's distance from Alpha Centauri A, was a prime candidate for being a planet within the star's habitable zone, potentially the closest exoplanet ever directly imaged. The discovery set off a chain of excitement and curiosity in the scientific community, as this potential Saturn-sized gas giant was thought to be located in a sweet spot that might harbor life. However, follow-up observations in early 2025 failed to detect the object again, leading to questions about whether it truly existed. Was this a planet or just an extraordinary false alarm? Alpha Centauri is a triple star system located just over 4 light-years away from Earth. It consists of 2 stars, Alpha Centauri A and B, which are a binary pair, along with a red dwarf star, Proxima Centauri, which also has its own exoplanets. In 2024, JWST's mid-infrared instrument, MIRI, used a coronagraph, a type of optical mask designed to block out the blinding light from the central star, to observe the region between 1 and 3 astronomical units, AU, from Alpha Centauri A. The team detected a faint point source at around 1.5 arc-seconds from the star in the 15.5 micron filter, which was consistent with the thermal emission from a planet. The object was estimated to be a Saturn-like gas giant, with a mass roughly 90 to 150 times that of Earth and an equilibrium temperature around 225 K, which corresponds to 48 degrees Celsius. The distance between the star and this potential planet, around 2 AU, placed it squarely in Alpha Centauri A's habitable zone, the region where liquid water could potentially exist on rocky planets or moons. If the discovery was legitimate, it would be an unprecedented achievement in exoplanet science, as it would represent the closest planet ever directly imaged around a sun-like star. However, things quickly took a puzzling turn when follow-up observations in 2025, conducted in February and April, failed to detect the object. To explain this discrepancy, the team conducted extensive simulations of possible planetary orbits. They found that if the planet's orbit was highly elliptical or tilted in a certain way relative to the star's plane, it could have passed behind the coronagraph's mask, making it invisible during those specific follow-up attempts. These simulations suggested that about 50% of the stable orbital paths for a planet like this would evade detection at those times. This opened the possibility that the object seen in August 2024 was indeed real, but simply hidden in the glare of the coronagraph during later observations. Adding to the intrigue, a 2019 study from the Very Large Telescope, VLT, detected a possible candidate in the same region named C1 using the NEAR experiment. If the August 2024 observation and the 2019 detection refer to the same object, it could mean that the planet's orbit has been consistently tracked over multiple years, lending further credibility to the idea that this is a real, albeit elusive, planet. However, extraordinary claims demand extraordinary scrutiny, and there were other possibilities to consider. The JWST coronagraph images could have captured an instrumental artifact, such as a speckle or noise pattern created by imperfections in the telescope's optics. To address this, the team performed careful data processing and subtracted out potential artifacts, using a reference star for calibration. The analysis showed that the detected point source was robust and not an artifact from the imaging process. However, since repeat imaging is necessary for confirmation, the mystery of the disappearing planet remains unresolved. Another possibility was that the object could be a background star or galaxy, which might have appeared coincidentally near Alpha Centauri A in the frame. However, due to the fast proper motion of the Alpha Centauri system, any background object would not stay in the same position relative to the star. The team's analysis ruled this out, concluding that the object was not a stationary background source. It was also possible that the observed point source was not a planet, but rather a clump of exozodiacal dust in the space between stars. However, Webb's previous observations had already set tight upper limits on the amount of exozodiacal dust in the Alpha Centauri system. For a dust clump to have been bright enough to mimic a planet at the right location would have exceeded those limits, making it unlikely. There was also the question of why previous radial velocity, RV surveys of Alpha Centauri A hadn't detected a planet in this region. RV surveys measure the small back-and-forth motion of a star caused by the gravitational pull of an orbiting planet. These surveys had placed stringent limits on the presence of large planets in the habitable zone, but depending on the planet's orbit, especially if it was tilted or eccentric, the gravitational influence of the planet might not have been strong enough to register in previous RV measurements. The mass range of the candidate detected by Webb was found to be consistent with the RV limits, which suggested that the planet, if real, could have been hiding in plain sight all along. The planet detected by Webb was likely a cold gas giant, akin to Saturn, rather than a small rocky world. The thermal infrared flux from the object indicated a temperature of around 225 K, which is too low for the planet to be self-luminous, like a younger gas giant. Instead, what Webb detected was likely a combination of reflected light from Alpha Centauri A and thermal emission from the planet's atmosphere. This temperature range suggests that the planet could be a Saturn-class giant, with a radius slightly larger than Jupiter and a mass between 0.3 and 0.5 times that of Jupiter. While gas giants themselves aren't considered habitable, moons around these planets, if they exist, could be. Large, icy, or rocky moons, if they retain their atmospheres, could potentially harbor life. However, Webb isn't equipped to directly detect such moons, so this remains speculative. Alpha Centauri A, being a near-solar twin, provides a unique opportunity for studying exoplanets. The system's habitable zone stretches from about 1.2 to 1.8 AU, with stable orbits extending even further to around 2 to 3 AU. This is precisely where the potential planet was detected. The proximity of Alpha Centauri, only 1.33 parsecs away, means that Webb can resolve the star's habitable zone in mid-infrared light, opening up a new era of exoplanet imaging. JWST's MIRI coronagraph, specifically its 15.5 micron filter, was key to resolving this faint planet. By using a technique called roll subtraction, where the telescope's pointing is slightly adjusted between exposures to subtract out stationary background noise, the team was able to capture detailed images of the region. The detection sensitivity of Webb, coupled with its ability to reject noise and artifacts, allowed it to image objects as faint as 250 K planets, at distances as far as 1 to 2 arcseconds from the star. This is a level of sensitivity that previous telescopes, such as the VLT or Hubble, could not achieve in mid-infrared wavelengths. So, what happens next? To confirm whether the planet is real, more observations are needed as the object or its orbit moves through the coronagraph's field of view. The planet, if it exists, will likely be visible again in the next 2 to 3 years, when its orbit brings it back to a location where it's observable without being hidden by the coronagraph's mask. Other telescopes, like the Extremely Large Telescope, ELT, and the Nancy Grace Roman Space Telescope, will be able to contribute by observing in different wavelengths and with next-generation coronagraph instruments, pushing the boundaries of exoplanet detection even further. If this world is confirmed, it would represent an exciting step forward in the search for habitable worlds. It is bright, nearby, and orbiting a sun-like star, making it an ideal candidate for future atmospheric studies. For now, the mystery remains. Is this planet real, or is it just an optical illusion in the vastness of space? Only time and further observations will tell.